I've created 3 virtual machines in my development environment. I have an Oracle database running called ASM02 running on one virtual machine. I have an Alloydb-Omni database server running on a separate virtual machine, and then Visulate Ora2Pg and Visulate for Oracle running on a third VM. I'm using the Visulate tools to look at the Oracle database that I'm planning to migrate to Alloydb, and in the process of doing that migration, I'd also like to do an application modernization. So the first thing I do is I navigate into I use Visulate for Oracle to look at the database structure. I see all of the objects are in a schema called RNT-MGR2. I see a fair number of tables and package bodies. Then looking through here I'm listing 146 tables in that Rent Manager 2 schema, and I can see a number of different column prefixes, database table prefixes. So there are some that start with ASM, then there are some internal tables here. Then some start with MLS, PR, and then finally I have some RNT ones. I happen to know that what that means is that the database itself is being used as it was supporting an application that was developed over a number of years and evolved over that time to add a different functionality to it. And a lot of there's a lot of commingling, so the different application functionality is being supported by different tables, and the way that we were distinguishing between them is using that table prefix. So the first application that I want to modernize is this property management software application, which was written quite a long time ago using PHP, and all of the tables for it start with the RNT underscore prefix. So when I look at those, I can see accounts payable, receivable, balances, etc. And we're looking at the accounts payable table here. I can see the table space it's stored in, the number of rows in that database. And if I scroll down the page, I can also see which PL SQL packages are based on it. So the second tool that I'm going to use today is Visulate's Ora2Pg implementation. And what we've done here is we've provided a user interface on top of the Ora2Pg Perl application that's been around for a number of years. It interrogates an Oracle database and then uses it to generate Postgres DDL from it. And our implementation provides a couple of things. First of all, we put a user interface on top of it. And secondly, we add this notion of a project. And so I'm going to I've created 4 different projects for the different subsystems that we're planning to migrate. So all of the tables all of the objects that start with RNT are going to be in the RNT schema, and then we have one for, some of the tables started with PR for public records, that was MLS, and then ASM. And if you see here, we have if you're familiar with Ora2Pg, you'll probably also be familiar that it comes with a very large configuration file that you have to tweak. And what this tool does is let you edit those via a user interface. So at the moment I'm saying I want to generate table DDL for any of the tables in this database that happen to start with PR underscore. So if I hit run on that, it's going to it runs through, it scans the database, and when it's finished, you'll see that we've generated the Postgres compatible DDL for the tables in that data, in the source database that started with PR. So the tables that we want to look at today are, we'll start with RNT, so I'm going to go and look at those, and I'm actually going to download the DDL for that. I ran this script a few minutes ago, so save link as, and I'm going to put them in a folder called Migration. So now if I go to that migration folder, there's my new DDL, and I'm going to connect to that Alloydb instance and create the tables from that DDL. So \i table.sql, and these are the DDL. These are the table statement, create table statements that we generated a few minutes ago. And there it is, it's created the tables for me. Now I'm going to go back and run Ora2Pg again, but this time using the copy command. And so what that's going to do is read all of the data from my source database and copy it into the target, the Alloydb database. So hit run again. And again, it starts with just scanning the object space, but now you can see it started doing that copy. So whilst that's running, I'll go back and look at the PL SQL packages that are related to the tables that we have here. And if I look here, it's listing all of the database objects that are dependent on, or used by, or used by, or required for a given object. So I'm going to go and look at one of the package bodies, and I can see there's a bunch of SQL statements in here, but this is the package body for the general ledger. And when I'm looking at it, what I've identified is that this database is using PL SQL for basically PL SQL APIs to implement business logic. Now, as part of my application modernization, I'd like to get that out of the database and put it in the mid-tier, possibly, probably using Node.js, but there are other options available to me. And so I'm going to use another feature of this tool set to help me do that. So what I'm showing here is everything that you see on the screen through this UI makes API calls to actually implement the logic. And so these are the APIs that are happening under the covers. So we have the page we were just looking at. Let me just scroll down. We were looking at the rent ledger package in the as a package body in that schema. So if I look here, I have the database schema, package body, rent ledger package, and when I run that API, let me just execute. Looks like I've already run it, but just to show there's nothing up my sleeve. There it is. The same information that you see on the screen is displayed via the API. Now, if you notice here, there's one of the parameters which currently has none. Says a handlebars or mustache template that can be used to transform the result. So what I've done in here. So this is I'm now logged into that Ora2Pg server, the one that Visulate's running on, and I can see, and I've written a handlebars template that I can use to transform the result set of the API call into a JavaScript module. So if I pass that in, let me go back over here and copy that, and then paste it into the template here. Now if we hit execute again, see what it's done. It's using the same information, but now it's going to generate a code stub with all of the SQL statements that were in that PL/SQL package, so that I can go and review them at a later date and convert them into library code for my API layer. There's another feature I can use. So if you look on the menu, so that the API we just called there is what populates this side of the screen. There's a separate API that populates the menu on the left, and if I run that one, you can see I get this list of objects. And if I call that with a different template and execute that, I can use it to generate a series of curl statements that I'm going to use in a minute. So over here, if I copy that command and then go back to my exit out of there. So this is the directory. If you remember, it had that we downloaded the table statement into. If I just add a couple of extra parameters to this, one is O code gen. SH. So it's generated a shell script for me. You can see what I have here is a bash script that will make a series of curl calls and generate the output as a file. So I just need to make that executable. And then run it. You can see it's generated the files for me, and if I were to browse one of those, see it's the same information we were looking at on the screen over here is in my file here. So if we head back to Ora2Pg, so it looks like the migration is finished. Let's just scroll down to the bottom, make sure it was successful, and it looks like it was, yep. So I can close this. And if I head back over to this window, so again, I'm going to log into that Alloydb instance and let's have a look at the data. So I'm logged into the Alloydb instance. I can select count star from RT accounts payable. And I see I have the exact same number of rows we were seeing before. Check that it, let's take a look at them. Yep, and they look pretty much what you'd expect.